Barry, come on up. From Hex, Idan from GitLab, Greg from GitHub. Greg from Jasper, and of course, Sean from Databricks.
Sorry.
Okay, so today we're going to spend a little bit of time going deep into the world of generative AI, large language models, foundation models, and this is an incredible panel that we pulled together that's been really focused on applied use cases. And the big TLDR that you'll see out of this is the incredible use cases that are occurring in the generative world are quite varied and quite profound. So let's just start off with the easy questions. What's happening in generative AI today, and why is this happening in such an accelerated fashion than we've ever seen in sort of years of work in artificial intelligence and machine learning? Maybe, Sean, you want to start?
Okay, yeah, I'll take a shot. I think most of the answer is ChatGPT. That got people to notice generative AI. It's actually been coming along fast, but it's been coming for a couple years now. But this got everyone to prick up their ears and listen. And when you do take a look, all of a sudden, even as a practitioner, you realize there's a lot more going on than ChatGPT. And it is fascinating to me how accessible these large language models are. You put text in, you get text out or images out. It's a very intuitive user surface, and that's why I think it's not just interesting for your average user like my mom, but for practitioners who have real use cases. They really do some interesting stuff, and that's why I think everyone's rushing now to figure out what can this do, how does this work, and how do I get in on it?
And as you guys have all started to apply generative use cases, and particularly building either specific domain-oriented large language models, I mean certainly the announcement with DALL-E this past week, Greg, some of the work that you're doing right now at Jasper, starting with OpenAI, but then extending that to other large language models. Just tell us a little bit more, maybe Greg, as a starting point, what surprised you guys through this journey of what you thought you were getting and what you got out of building with a generative first experience?
Yeah, I think to your point about ChatGPT, I think that woke the world up to the power of what these models could do, and it woke up not just the AI early adopters and nerds and those people that were really into it, but it was kind of the moms and pops. It was the big businesses that now couldn't afford to ignore this. The small businesses, everyone was really turned on to it. And as we started, we'd been working on some things earlier on, and I think a lot of what we found is that we could get an edge and create a better experience for users by trying to figure out how to leverage these models as best we could and really trying to understand them. And I think what we found that was a little surprising, or maybe not, I guess, but looking back now, is just how much of a black box they really kind of are, and trying to understand almost if each model is a different almost persona of AI, as maybe as freaky as that gets, talking about AI that way, but thinking of it they each have their own strengths and weaknesses, and they're not always obvious, and so trying to explore which models are good for which use cases and which ways, and then understanding maybe how to experiment around those things with the not so obvious use cases. What we found is that OpenAI, their models definitely have a certain sort of persona or a certain set of strengths and weaknesses that are kind of common to a lot of them, whereas other providers, some models that we've created in-house at Jasper, they all kind of have different, veins or threads of what they're really good at and what they're maybe weak at. And what we found is that even though they become super powerful, that you could take any of them off the shelf and do a lot with them, it's still never a one-size-fits-all, at least in the best you could get out of them. There's still a combination of things that you could do, leveraging either different models or a large language model with something else, to really produce the best, whether it's text output or image output or whatever it is. So it's been a lot of experimenting and finding that trying to really get inside the model, so to speak, isn't really where we've had success. It's kind of been just honestly experimenting and trialing things and combining things and seeing what we can understand about them from that perspective.
So let's pull on that thread a little bit. You indicated that models have personalities, right? And so there's a worldview that there's potentially a single model emerging. We won't name who's building that. that there's a possibility for AGI coming out of this single model emerging. Barry, you had some thoughts before we got on stage in terms of like, is that the way enterprises are going to consume things over time, or is there a different worldview that's also emerging simultaneously?
Well, I don't have a strong worldview on like how imminent AGI is. I think there's some much smarter people who are.
I just quoted in Reuters this morning about that. I said, no, AGI is not along its way. So I took a position on it for a reason.
I think there's an interesting thing when we go and talk to customers, especially larger customers, both within the context of Hex, but also just more broadly on like how they're thinking about using and applying generative AI. I think there's this interesting opportunity and challenge that you're going to see people using lots and lots of models. I mean, today we think generative AI, there's like effectively one API that you can go and use, OpenAI, but I think a year from now there's going to be at least a dozen. The ones we know about, ones we don't know about. You love the big cloud players, lots of startups. And I think what you're going to see is companies, and I know Jasper, they're doing this, they're adopting, behind the product, like a bunch of different models that can be used. I think you're going to see big corporations do this and across all the different surface areas of where they're using generative AI, both internally and for their products. And so I think you're going to see a super heterogeneous landscape of different models and different things that people are using, either just different providers, because this department had a better relationship with this other company, or models that are purpose-built or fit for purpose for different types of things, or a thing you fine-tune for a single use case. And I think that's going to create a lot of chaos. I think it's going to create a lot of confusion within these big companies. I mean, anyone here who's ever worked at a big company, or if you're selling to a big company, you know that if you go and ask them, like, oh, what do you use for data warehousing? If you go and ask like a big bank, what do you use for data storage and data warehousing? It's like everything. We have one of everything. You're going to see the same thing with these models, and I think there's an interesting challenge and opportunity around managing that and observing those and understanding how those things are performing and also the risk associated with that.
Idan, at your time, particularly focused on Copilot, right, and the work that the team at GitHub has done, I mean, for anyone who's sort of had an experience around Copilot, it's probably the most profound change in programming that we've seen in probably a decade or more. So how has that sort of human-machine interface sort of changed using generative AI? And particularly, like, how does that persona for the developer in this case, find a different way of working? And was that what you were going about doing when you guys went down the Copilot route? And where do you see this go from this moment on?
Well, that's not a big question at all. Wow. Well, I gotta admit, I was a skeptic in the beginning. Like when we first started out with Copilot, like 2.5 years ago, there wasn't chat. It wasn't the age of AI. It was sort of the first mass market application of generative AI. And the truth is that it's I was very glad to be wrong. Like it turned out to be actually incredibly useful to the point where I never want to code without it again. It's incredibly helpful. But I think we're just starting to scratch the surface. Like there's more modalities. Ghost text is not the be-all and end-all of generative AI. Like, yeah, it's got a lot of great qualities, but that's not the only way that things can be. Definitely more applications. Like we're looking at Copilot outside of the editor. Like how can we help developers with all of these other tasks and bring generative AI to help with like not just writing tests or writing code, but also helping me collaborate and summarize and bring other people into the discussion with me. Docs, that's like a huge part of like what we do as developers is, looking at the documentation, trying to figure out how do I do the thing that I want to do? How can we basically speed people along that curve? If you think of the computer as an instrument, like how do we get people to play their first song? How do we get more people to play this instrument? I think we have a generational opportunity right now to bring more people into the field that maybe don't have the advantages I had coming up. And where previously we've said like, oh, it would be really nice if we could get more diversity into computer science. Now we actually have the tools to make that happen. So I look at that when I think about the future of generative stuff. At the end of the day, I want to give bionic capabilities to developers. I want them to step into this exoskeleton that's powered, and whatever they want to do, they can lift buildings and jump really high, and I don't know, whatever. So by any means, and in a lot of different situations, it's no longer going to be oh, here's one feature in one situation. It's going to be a million things in a million situations, and use, as Jasper said, sorry, not Jasper.
Greg,
Greg, not Jasper. A lot of different models in order to accomplish that. It's not going to be one model fits all.
Well, great. You kind of alluded to something, which is the models have their own personas, right? And in essence, most software companies who've gotten to a level of scale and succeeded, they've found the persona that they pursue and really tailor their products and capabilities to that persona. Is there a world, and maybe Jasper's probably one of the first highlights, where there's one model per human persona, one machine LLM persona per human persona? Just talk about that a little bit more in Jasper's experience in transforming how content writers work today.
Yeah, and so maybe for a little bit of background, for those who don't know about Jasper, our main target customer, I'd say, is business people working professionally to create content. The most obvious use case being people on marketing teams, but really can extend to anyone creating content. It could be engineers creating documentation, things like that too. But what we found is early on, we started to discover that customers, users, really have this desire to have a large language model, or what they thought of as a large language model, but generally they wanted AI that was more accustomed to what they were doing and more personalized for them, that could speak like them or know about them, have facts about them, all those different types of things instead of feeling kind of generic. Because after a while of using, especially some of the earlier models, even from OpenAI, you start to kind of see these patterns where, okay, it's great, but it does start to kind of feel generic, and it's harder to differentiate between who's using the model to create the content, and really it kind of almost becomes more the model itself. And so some of the first things that we looked into was, well, what would it look like to create models for every customer? And obviously, at first glance, you realize that's not the most economical way to handle that. If you're looking at creating a 175 billion parameter model for every customer, and we've got however many customers, that's not going to scale very well at all. But even aside from that, we started to kind of poke at things around that and found that from our experience and then this kind of comes back to what I was saying before about the models are kind of these black boxes, and when you try to open them up and do whether it's a lot of fine tuning to an existing model or something like that, we found there's actually different ways to get the desired result without doing those things, where I guess long story short, instead of creating a whole new model for every person or for every use case or for every whatever it is, personality that you want, there's things that you can do around that model to create that desired effect. There's been a lot of things coming out recently in the press about companies finding a lot of success, including Jasper with vector databases and vector search with large language models, or things you can do with adapter models, or things you can do even just with more traditional AI technologies in concert with large language models to create a more personalized experience. So it might not be that you have your own large language model that's for you, but you have sort of this orchestration of technologies working in concert that does fit you and fit your use case and may understand more about you. So that's a lot of what we've, in fact, I'd say the biggest thing that we're focused on right now that we're releasing features around is the idea of, there's maybe generic off-the-shelf large language models that are very powerful, but then how do we personalize them? How do we make them more suited for what we're specifically doing, either as companies or even as individuals?
One of the things that I had a chance to talk about more recently is the fact that every software category is going to need this idea of its own specific category dominant large language model, but it's not just about that large language model. It's the fact that you still have to build great UX. You still have to build a great workflow. And certainly Jasper's experience, sort of really shows what's possible. For those of you who don't know, Jasper's either the second or the fastest growing software company ever as of this past year. So, Sean, so Databricks doesn't have to do any of this stuff. Like, you're a billion-dollar business now. It's been an incredible journey to watch what you and Ali and the rest of the team has accomplished in the last, going on a decade now, right?
Yeah, but just about.
Congrats on this journey. Why did you guys go down this path of like announcing and even working on something like DALL-E? What was the creative impetus? Where do you see this impact of where everyone went down this path of like building these, several $100 million expenditure of compute large language models? You guys come back and spend $30 on a model called DALL-E, which has potentially even outperformed some of the models that have been in market to date.
Yeah, that's worth explaining. And I should say I work with that team. I won't take credit for what that team did, Mike and Mate and all them.
Of course.
But yeah, let me work backwards to how we got there. Because Databricks isn't really a researchy type of company by nature. And I think what was received in the announcement wasn't quite the point. Yeah, there was a model that got created, but it was really more about the idea and the process. Maybe I don't need a massive model to be good at a specific thing. And I think that's not even necessarily news. That's an idea that was had, I think, weeks before you heard about DALL-E. So it makes more sense if you see, I think what I see at Databricks from customers. Hearing about ChatGPT, yes, now everyone is infused with a mix of FOMO and fear. I need this. This looks like it's going to change everything. What does it do? And how do I get on top of it before it gets on top of me? And then fear, as you look at the dominant player in this space, OpenAI, which is great, actually. It's good value for money. It's a great model. And certainly with your enterprise hat on, maybe your data hat on, you say, well, this is a little scary. I'm going to send my data to this company and trust they're going to give me answers back and keep it secure. I need to do this in-house. And then you realize you can't do it in-house just off the shelf. It took these researchers years and millions of dollars. So that doesn't seem realistic. And then maybe you also separately observe that the real bottleneck in all this is data. It's not the compute, it's not the research, it's not the tools. That's fairly commodity, but data. And the thing you need to do with these LLMs is probably not, you don't need an AGI. You probably don't need a chatbot. You're trying to fill out RFP responses from your previous RFP responses. And you have that data sets that OpenAI doesn't. So all this kind of leads you to this need. Like, I want something that I can feasibly manage in my own model. Help me do that on my data. And that's why this idea that came out of Stanford really was so appealing to jump on and push. Sure, take a big base model, take your data, tune it in a pretty easy way to get something, let's say the single billions of parameters size, which is pretty manageable. And that is going to be a minor subplot in this whole story for, I think, this year.
Well, we're going to spend a little bit of time on RLHF and private data. I'm going to come back to that. But before I do that, Barry, you made some pretty interesting choices going down the path of hex magic, right? And it's a wildly beautiful experience to see what a generative SQL experience could look like. Tell us, what were the trade-offs? Clearly you built on top of OpenAI. It's been seems like a pretty positive experience. Tell everyone how the journey has gone.
Yeah. So just for folks who don't know, we released earlier this year a feature called Magic in Hex, which is basically, the shorthand pitch is like Copilot for data, to just piggyback off Idan as usual. And it allows users to generate, edit, debug, and document analytics code. So if you're writing SQL or Python or R in Hex, you can invoke these Magic assistants that will come and help you do that. And I think we had actually first prototyped this a year ago. We had a hack week. It was exactly a year ago. It was April 11th. I was just looking at it the other day, where we had done a first version of this using the GPT-3 API, which was available at the time. And the API wasn't quite ready. It was kind of shaky. And also, it wasn't clear to us how exactly this was going to get used, because I think our fear, or the thing we had initially thought was oh, this can just generate the thing for you in one shot. And I think as we iterated on it and we sort of came back to it over the summer and fall of last year, the insight that really we zoned in on, and the thing we decided to really adopt as our core focus with the magic features, was this is about augmenting and accelerating the current users we have. We have thousands of people who use Hex every day to ask and answer questions of data, to build visualizations. Like, mission one for us on everything we do is making these people's lives better. And I really think that, like, using that as our sort of central focus, it's not about, like, hey, all of data work and all of data professionals are going to be replaced by some, like, black box or, like, some, one text box where a business stakeholder comes in and, like, types some question and gets back a perfectly formatted answer with properly built charts and explanations and all of that. Like, I don't think that's going to happen anytime soon. And so for us, it was really about how do we incorporate these generative features in the existing workflow in a way that feels really magic. And so, we had to do, even as we were iterating on it, there was some really new UI things we kind of had to break into. And candidly, I think one of the most exciting things about generative AI as a product builder is it is, like, for the first time in a long time, like a new UI surface area. Like, we're going on a while, like, since, like, 2008 really, with the App Store coming out, of, like, kind of the same UI stuff, and it's like this kind of new exciting frontier and front on UX. And so for us, it was fun, and it's been fun, and we've got more stuff coming down the pike in terms of, like, what does it look like to have a human partner with software in this sort of assistant way? Like, one's mind jumps forward, or jumps back, I suppose, to, like, Clippy. Is it like this little assistant that hangs out alongside? And so that was really fun, and I think that we were alluding earlier to, like, it's about the UX. I think that the APIs, the AI itself is a commodity, more or less. And I don't mean to elide the nuance of, like, okay, are you using, like, an off-the-shelf one, or are you using something like DALL-E to deploy your own? But, like, access to the base LLMs is a commodity. Everyone here can go spin up an OpenAI account right now. It's how do you package that in a UI in UX that's really, really thoughtful about, like, the interaction it's going to have with the human, the feedback loops, and how that changes the way people are working. And that's been the really fun and really exciting thing for us, like, within the domain of data.
One thing that Andrew Ng called last year was that everything that we've known in the AI world, particularly around machine learning, is really pushing itself from a model-centric to a data-centric world, right? And to your point, Barry, like, the models are becoming so ubiquitous, right? Yeah. Whether you get it off the shelf, whether you build it, whether you curate it from a number of, like, sources where you're kind of building your own ensemble across these models, it's still a data-centric world. So when we think about that data-centric world, I mean, there's an incredible number of awesome data engineers here. How do we have to think about this from a data engineering standpoint? Do LLMs need their own special storage? Do we have to think about ETL or ELT differently now that we have this sort of massive rise of LLMs in the market? Is vector databases a thing? I don't know if anyone, doesn't matter.
I mean, I'll definitely draft on what Barry said, that like, the end goal needs to be happiness, satisfaction, and how do you deliver that? By any means. I think how those underlying data primitives change depends a lot on where we're going next. There's a lot of talk about, like, how are we going to make LLMs stronger, better? How are we going to train them? How are we going to fine-tune them? And that costs a lot of money. And it's kind of like, oh, I have all this horsepower, I need more horsepower. When in reality, I don't think that we've really fully tapped the power of the models that we have today. And so you asked about vector databases. I see a lot of mileage still to get out of techniques like retrieval, where instead of fine-tuning, which costs money and needs GPUs that maybe I don't have and everybody else wants. But if I could do embeddings and then use that to better craft prompts, then I can elicit better responses from the models I have today, not the models that we'll train tomorrow. And then I also don't need to train my own models. I can use the off-the-shelf ones, but get more specific to my purpose responses out of them.
The vast majority of the effort we are putting in, that the team who works on Magic is putting in right now, and I think the real crux of, like, what it takes to be really good at this stuff is, like, the data prep. It is like we now have, like, dedicated ETL pipelines and storage and processing steps that we're taking, and a lot of the iteration is on that, on how we're using the data to then prompt the model. Like the API call is the easy part, right? It's like, it's everything up into like, what do you fit in that context window, and how do you process what you're bringing back? For us, the opportunity with Magic is particularly exciting because we already do have this pretty big base of people writing queries every day and connecting us to their warehouses and their data catalogs and enriching us with their DBT models. And so like, we have all of this context and data, and like the hard part is like, what of that is useful to be able to get the right response from the model? And how do you synthesize all of that into a prompt that's going to help do that? And so the processing steps and what you do to bring that together has actually become probably the single biggest point of effort for us right now, besides just the UX.
I think to go along with that, between the four of us up here as panelists, Jasper definitely has the least technical target user, right? Where they're marketers, and that's not to say they're not technical. I think there's actually a lot of technical expertise in marketing that I find really fascinating, but they're not data scientists or data engineers as much by trade as many of your customers would be, right? And so to go along with that, though, it's getting the data that a lot of them already do have. Like for Jasper's customers, a lot of times it's not data as we think of it. It might be like previous content that they've created. It might be like their marketing site that they want to have Jasper or their large language models understand better, and that's sort of the data set that they want to use. And so very similar to what you're saying about a lot of focus being spent on like how to see like what's important data to use, what's not, how does it get consumed and used in ways to create better prompts and then therefore better output. I think it also kind of comes back to that concept of like a lot of this is still experience. At the end of the day, it's the user experience. And so for Jasper's customers who are going to be less technical, how do we make that really, really simple to where they're not having to do feature engineering, or they're not having to go and like transform and do all these things to their own data sets. Again, if it's like their marketing site, we're trying to make it as easy as possible to just get that ingested in, and we'll do all the magic on the back end of it to make it so it can be used for the large language models and other AI technologies to produce better outputs for them. And so I think I think what's really interesting about large language models maybe specifically that is different than before with all this, because I think some of this around experience has always been true, but I think, again, we're working with large language models to even do some of the ETL and the data curation and things like that. And I could be wrong. I'm not sure that was like one of the first use cases that many of these large language model providers and creators had in mind when they created them. But again, it's one of those emerging capabilities that we found that's really interesting to use.
So when we think about a lot of the input that's coming into the large language model, there's also, as far as data, right? There's also a tremendous value in the output. And so let's talk about that for a moment. Inference, right? There's a lot of opportunity in what's generated from an inference standpoint, what the possibilities are in RLHF in terms of reinforcement learning through human feedback loops. It's also a very expensive proposition today, particularly on some of these large scaled out large language models in terms of the cost of this inference. So how do you guys think about this today as far as where inference is, how RLHF and other methods of improving models over time from the output of this data that's generated is going to change the way we work? Sean, you might want to start.
Okay, yeah, there's probably two questions here. First, inference, what are the issues there? I mean, you're right, I think it's not obvious if you haven't worked with large language models how big they are and how compute intensive they are. It's one thing to say, that's cool, that's a 12 billion parameter model. It's another thing to get it to respond in well under a second. And you can do it, but it's a whole other world of engineering and tools and concerns and trade-offs. So certainly, the places that I'm seeing people start are not real time if possible. There's a lot, you can cover a lot of ground in batch and streaming, and then this stuff gets easier if you're not as concerned with latency. But yeah, inference has suddenly become, I think it was previously not a big deal, at least in our world. Sure, you made a XGBoost model, you want to serve that in real time, it takes a millisecond to score, who cares? Now that's not true at all. RLHF, I don't think I have strong opinions on that yet, so I'm gonna pass on that one to others.
Me? Oh,
yes. You're in the middle of a big RLHF journey.
Yeah, no, I think I think to that point, like maybe more on like whether it's RLHF or something else. I think something, again, another emerging capability that's been talked about more recently, as in like the last week or two even, is this idea of like critiquing the outputs using another large language model. And then even like making suggestions on like how to improve said output and things. And so I think like there's this combination of like humans in the loop, but then also other large language models in the loop doing some of that too. But I think the idea is, I think with like ChatGPT, obviously OpenAI used human feedback to do more of the fine tuning and affecting the model itself. Again, for a lot of us that are wanting to create large language models or use large language models, we might not have the capability to do that. But we could still use the output, do something similar to that, and instead of using it to fine tune, it's almost change the prompts, change the way that we're getting data, putting into the model for the input. And again, using large language models even to critique themselves in a way to help us understand and improve how we go about doing that. So I think there's a lot that we're still figuring out with that. I think that's a good example of maybe a more like traditional method of improving a model that can work, but then there's like other capabilities and things that we're really trying to still understand that can help us make models better from using the output that we've gotten from them.
One quick point to make that occurred to me on the subject of output. We were just talking about Dolly and Alpaca. I don't know if people didn't see it. The real trick there was to take one model and fine-tune it on the output of OpenAI. So the whole trick there was take the output of a model and use that to make another model. It's an interesting set of issues there, but totally possible. The output can be the input too.
Well, one of the issues being OpenAI's terms of service, right?
Yes. That is an issue.
George, you talked about cost of inference. I think when we were looking at this like a year ago, we were like, well, look at the rates for these API calls, and if like our users actually adopt this, it's going to like bankrupt us. We're going to have to charge more, and we were like starting to get down this path of like, well, how are we going to price for this and all this, and then we started really experimenting with earnest a few months ago. Like we're going to propose this in production, and again, we started penciling the math on like the cost of inference. It was like, how are we going to charge for this? And all of a sudden, we have this pricing conversation. And I'm like going to OpenAI, and I'm like, hey, could we like negotiate? Because if our users, if this really takes off, we're going to have to. And they're like, no, don't worry about that. And I was like, well, what do you mean? They're like, I was like, well, what? Like, okay, here's early access to this thing, and it's a new model, and it's 1/10 the cost.
the price.
I was like, oh, okay, I see why you weren't like trying to negotiate down. I was like, if you would have negotiated like 1/3 the cost, I would have been happy. And you're like, here, the new baseline's 1/10. So my lesson from that, and I think in general when we're building with these models and we're thinking about cost, is it's okay to live in the future a little bit, because I think the rate of cost collapse we're going to see is just going to come so fast. I think you're going to see multiple factors pushing this. You're going to have competition in the market. So OpenAI is just going to, they're going to have more competition, and there's going to be downward price pressure. You're going to have we're all going to get more efficient and better at training and inference costs. Like we're so early in the process of understanding like how to optimize this from a compute perspective. And so I think as builders and as people like looking to leverage this, like I'm encouraging our team to like not worry too much about the costs in the short term, because the slope so far has been like this, and if we extrapolate it just a little bit, I think you can assume that there's a lot more efficiency ahead.
I think to add to that, talking with leaders at OpenAI and Anthropic and Cohere and others, the way they talk about their own models is still very like they're big and inefficient, and there's a lot to get out of them to make them more efficient. So yeah, I think you're absolutely right that we're very much in this phase of like we've discovered this really powerful technology, but right now it's just I'm a big Formula One fan. We're in Austin, Texas, right? So I guess it's a good analogy too. There's a race here, in case you didn't know, that they do every year. But in Formula One, for example, like engine technology kind of boomed when it was like, oh my gosh, like if we add more cylinders and make them bigger, we get more power. And so you had these huge fire-breathing engines that produced, 1,000+ horsepower that were ginormous and sucked in gasoline at a crazy rate and everything. They're very inefficient. Nowadays, a Formula One engine, I think, is like 1.6 liters and still produces over 1,000 horsepower. So, I mean, the efficiency is phenomenal. And I think we're kind of at that peak with AI where, at least with Gen AI, where we're kind of in this like really big engine, big cylinder. Everyone talks about like how many hundreds of billions of parameters these models are. It's very soon, if not like last week, apparently, we're going to start talking about how small they can be. and how that can be really powerful and more efficient, that they can be better for certain use cases and more efficient from an inference and latency cost.
Yeah.
One more thing, by the way. You were talking about reinforcement learning and then logging or looking at responses and the outputs. We're not doing any hardcore RLHF right now, but one thing that's funny when you start going down this path is like there's a lot of new and wondrous things when you're working with generative AI, but there's also some stuff where you're like, this is just everything is old is new again. And it's like one of the most important things is like logging, like you're logging like what the prompt was and the response and like what version, and then we do experiments now, so we have experimentation, and like I think there's a lot of things that have become like emergent best practices, and there's certainly companies focused on experimentation like Eppo and StatSig that are like, I think will be more relevant than ever actually, because especially with like these like kind of stochastic models, with models that are changing very quickly, where you are going to be wanting to iterate on the prompts while the model is also iterating its versions, and you're having humans giving you feedback on how that is. Like, we're spending a lot of our energy, as mentioning like on the data prep. Like a big part of that is like setting up our own experimentation framework and our own logging and our own data storage and that entire pipeline, because we just think there's ways in which we know that's going to be useful today, and there's also like ways in which we're like, hey, we just know like having this data and being able to iterate on it and run really good data-driven experiments is going to be like the thing. And I would encourage anyone else like starting to work with generative AI to like put in that effort up front, because I think it will pay a lot of dividends down the road.
Yeah, I definitely, that was definitely our experience also, specifically with Copilot. Like, the solution space is so large, and it's so easy to just drown yourself in like different combinatoric possibilities of like, well, what if we try this style of prompting? And what if we try this kind of like input? And what if we try that? And all of a sudden, you're sitting there looking at a dashboard with like 49,000 different things. And like, I remember this from the early days of Copilot. We're like, okay, we have 3 like different prompt strategies times however many languages, because it worked well for Python, but maybe less well for, I don't know, Haskell, because there's less Haskell out there in the world. And then, but what if we also control for geo and latency? Like, what happens if we add another 1/10 of a second to the amount of time until we show the prompt? Like, and all of a sudden, bam, I've got 40 charts. And what does it mean? And that's really hard to interpret. But coming back like a step to the compute side of thing, I'm less worried about inference. I'm more worried about like, where am I going to get a GPU? Like, I would really like Mr. Huang to like back the GPU truck up and just throw H100s at me. And the new models, they take only the big GPUs because they need that amount of memory on board. Like, very often I couldn't pay to even have the GPU to run the inference on. That's the real problem that I face right now. It's definitely a short term. Like, I'm sure the supply chain type stuff will ease up, but like.
Yeah, the GPU undersupply is a massive challenge for the next several years. I don't think that's going to go away anytime soon. There's certainly some work that's being done on new chips that are just AI specific, that are happening, that go even beyond GPUs. There's work that's happening in terms of custom silicon that you can specialize with FPGAs, but in the near term, we are a GPU-bound world in that regard. And as we think about that, right, so there's this sort of limitation on GPUs. There is another limitation that we're about to hit when it comes to public data, right? Because if we look at GPT-4 and this sort of GPT-4 style of models that are being built by Anthropic, Cohere, AI21, et cetera, it's likely going to lead into somewhere around 1 trillion parameters, which is incredible when you think about it, right? But every one of these generational efforts that have happened in the foundation models up to this point, we're going to see another order of magnitude emerge. But when we hit that next order of magnitude, let's just say, the 10 to 25 trillion parameters, there's a tiny little problem here, right? Which is, even if the loss function on these models continues to perform as well as they have, which is amazing that transformers can do this, we're going to run out of human corpus. Like, we don't have any more publicly available data to be able to train these models. As someone who's kind of been at this for a little bit in both public and private use of data, how do you guys think about that right now at GitHub?
I think I'm going to come back to what I said earlier, that the model that we have, the bird in the hand, we haven't even come close to like tapping the potential of that. I think maybe it's the wrong question. We should be thinking more in terms of how are we going to do things like retrieval and prompt craft better and get more out of the models that we have today.
There's more work to just be done and just optimization at this point that we shouldn't worry about, running out of corpus anytime soon.
Yeah, it's like, what do I need more corpus for? To train better. But what's the purpose of training? It's to make the model better. But the model's pretty good. So is that really the most important place to spend my time, energy, and money and GPUs? Then I don't know. I don't necessarily think so. And also, fine-tuning has this problem of you fine-tune or you do more training, and then the model knows about whatever existed up until that point. And it doesn't know about anything that happens later, right? So techniques that mash models together or retrieval, which I keep coming back to, allows me to use the same model we trained last month for however much we spent on it, but get results that are fresh and are able to point to their sources or cite their sources better with the model that we have today, and they remain fresh forever. I don't need to constantly be retraining to teach the model about new developments in the world if I do a better job of prompt crafting. But that's so much trial and error. So
there was a paper, a couple of months ago. I want to call it the chinchilla paper. It wasn't written by a chinchilla, but the question was how do we make progress? Bigger models, longer training, or more data? And basically the answer was more data. That's what we're bottlenecked on. So to your point, I think data is the issue, but to Idan's point, I don't know if we're close to the point where we've exploited all known human data, public data. But do we even need to be to solve particular problems?
Probably not.
I guess that's where my angle's coming in. Your business problem is probably not, I need an AGI. Your business problem is probably much more specific, and you do have the data for it. Data is still the bottleneck, but it's private data.
To burying Greg's point, the private data becomes more and more important, much more sooner.
Yeah, I think that's the thing. It's hard. The rate of change is so fast, but also it feels like a ways off. But I kind of don't doubt at all, and I think it almost feels obvious that 5, 10 years, whatever long enough horizon you want to put on, which is probably even really long in this space, the future is where you have probably these foundational base models, but a lot, potentially constant fine-tuning, retraining on private data, and whether that's your company and you are able to leverage a base model and then have it continually retraining on the corpus of private data that you are producing as exhaust from your operations every day. Or in private, and we're talking a lot about B2B or whatever, but in your personal life, Apple certainly I think has been on the forefront of on-device training, and you already see this with a lot of stuff with Siri and the way that they do stuff on the iPhone user. There already is a good amount of training that's happening on your phone with your photos and stuff like that. And so I'm very excited to see, I think the corpus of data, George, the corpus of private data out there, whether it's photos or texts or emails or love letters or whatever you have, having that be able to be part of the training in a secure way, I think is actually probably the most exciting frontier that we're going to get to, and I'm very looking forward to that. It's a little dystopian too. I rewatched Her recently, and I'm ooh, that is.
It was weird how prescient Her was.
It's just it's aged well, but also not well, because it will be interesting.
So last comment and question for everyone in this audience. I don't know if it's sort of landed upon you, but hopefully it has. In the last 6 months to a year, we're embarking on an incredible journey that, in my view, will certainly transform all of software and most likely all of humanity. And so when we think about that journey that we're all on for this next decade and beyond, what are some of the sort of parting words that each of you have as we're undertaking this incredible journey together?
Okay, I think one message to this audience, who I think is largely a data audience, is good news. I think data is probably the most important element here. So you're very well positioned to be a big part of the AI revolution.
Perfect, Sean.
Yeah, I would say that we're at a point now where it's more accessible than ever, generative AI that is, and that it certainly can play a part in a lot of what we do, both what you do specifically and then what you're trying to accomplish for your customer, your company, your personal endeavors, whatever that is. I think it's worth investing some time into understanding how Gen AI can play a part in that, and it may not be obvious.
Where we are in the hype cycle right now is oh my God, chat, that's mind-blowing. I didn't know a computer could do that. But I come back to what Barry said earlier. It's all about value and happiness, satisfaction. Like, that's durable. That's going to stick around. And making sure that whatever you're doing is not just being impressed by what the computer responded, but actually doing something that's going to make developers or whoever your customer is happier. That's peak concern, and that's what I think about every day.
I'm very worried about. I think we have to. I am trying to contribute in some small way, and also like potentially delusionally optimistic that generative AI is going to be a thing that will help amplify and augment and improve the human experience. I think if it turns out to be something that sidelines humans or potentially furthers the sort of quasi-dystopian type thing that we might have going on with some of our technology today, there'll be a lot of societal upheaval. So I want to invite everyone who's here, like who's building software and thinking about this, to like help contribute to like human-centric solutions. Because I think if we don't find a way for that to be how this manifests,
Barry's absolutely right here. I mean, when you think about this, like there are sort of forks in the road here, right? And things go really badly, things go really well, or somewhere in between. I would kind of close with this and say, like, in 1960, J.C.R. Licklider wrote a paper on human-machine symbiosis. And what he said, ultimately, was that machines are here to help humans do greater things, to be more creative, to be more productive, to 10x, to mech suit what we're capable of doing in our work lives, in our personal lives. And I think where generative AI could lead us is exactly that, this opportunity to have mech suits available, like the ones that you've built today. So really important to give this sort of audience and this panel here a great round of applause. They're doing incredible work in this area. Please spend time and talk to them. Thank you again, everyone.